All right, had to pause for a moment. So anyway, problem 3. Again, what I'm going to start with are the different transformations. So the 2 is going to make it stretch 2. The 3, that's our house number. It's going to go left 3, and then the 4 is going to make it go down 4. So again, when we make our T-chart, leave out the left, right, up, down numbers, but apply the stretch, compress, and the flip. So we will be using the 2 over x of our parent function. We'll use the same values, and I'll be putting those values in for x. So when I put -2 and I get -1, then I get -2. 0 doesn't work, then I'll get 2 and I'll get 1. And again, I won't graph these. I will actually apply my left, right, up, down to my wall. So the first wall is I'm going to move it left 3. And I want to remember that that is at x is -3. And then my other wall is going to go down 4. And that's going to be at y equals -4. So now what I'm going to do is graph my points with my walls acting as my new x and y axis. So I'm going to start with the -2, -1, go left 2, down 1, and then left 1, down 2, and I'll get my first curve. And then again, from what I consider to be the center, I'm going to go right 1, up 2, and right 2, up 1, and get that curve. And then I'm going to start writing coordinates for the arrow. So again, what I'll do is I'll start with the arrows going left and right. On the left, x is getting smaller, and I'll figure out the y. And on the right, x is getting bigger, and I'll figure out the y. Then I do the up and down. I'll get the x in a moment, but the y is going up, so that's infinity. And then the arrow going down means that the y will be -infinity. And if I look at my asymptotes, those will tell me the missing numbers that I need. So my missing x's will be -3, and my missing y's will be -4, because the walls will prevent the y's from going up or down, and it'll also prevent the x's from going left or right. So starting with domain, remember domain is x. My smallest x on the left side is -infinity to -3, and then I hit the wall and I start back at -3 on the other shape and go to infinity. And range is my y, so the shape on the left, I start out with -infinity to -4, I hit the wall, and then I pick back up at -infinity and go to infinity. Or I'm sorry, pick back up at -4 and go to infinity. So these are new, but they're definitely something that's doable. I want to know what the x-intercepts are and the y-intercept is based on the graph. And remember, these are the original x-intercepts and y-intercepts, and I didn't graph these very accurately. So what I'm going to have to do is try to figure that out. So my x-intercepts, anytime a graph hits the x-intercept, we're looking at y to be 0. So what I'm going to do is go to the original equation and take g of x, which is the same as y, and put 0 in for there, and just solve for x. So to solve for x, I got to get 2, 3, and 4 to the other side. So first I'm just going to add 4 to the other side. And then since this is a type of solving problem, and by putting a 1 under the fraction, I can think of this as a fraction equaling a fraction. And there was one method when we solved that we said we could just do cross products. So 2 times 1 is 2, and then I'll have 4 times x plus 3. To start solving, I'm going to distribute the 4. And now I'm just going to work to get that x by itself. I'm going to subtract the 10 first. And then after that, I am going to divide by the 4. And when I do that, my x-intercept is at -2.5, which, if you kind of look at the graph, so if you look at the x-axis, you can kind of see that there, that would be close to -2.5 if I actually graphed it correctly. So the next thing I'm going to do is figure out the y-intercept. And all y-intercepts are when x equals 0. So what I'm going to do is just go to my original equation and put 0 in for x, and I'll figure out what y is. All All right, so first I get 2/3, and then I'll need to do 2/3 take away 4, or I'm going to add the opposite over -4. And now I'm back to adding fractions. When I add fractions, I need a common denominator, and that common denominator is going to be 3. So my first fraction I can leave alone as 2/3, but the other one I'm going to multiply the top and the bottom by 3. So I get -12 over, I'm sorry, not negative, yeah, -12 over 3. And then I'm going to add them up, and I'm going to get 10/3. I'm sorry, -10/3. And that's going to put my y-intercept at about, as a decimal, -3.33. And, you know, I didn't write my answers in here. So here's my y-intercept as a decimal. And then my x-intercept as a decimal, which I forgot to do. And just to point out, you know, a y-intercept, where's my graph hitting the y-axis? About there. And if you look, that looks about -3.33. So just remember, x-intercepts, that's the x-axis, and on the x-axis all the y's are 0. And then y-intercepts, that's going through the y-axis, and that's when all your x's are 0. Okay, I'm going to let you try number 2 now. Just heads up, there is a flip on it, but I'm going to move on to the other part. I threw in a blank page. All right, this page is all about simplifying. You will have to factor every numerator and every denominator. When you get to your division problems, you'll need to copy dot plot, but I'm going to do, let's see, I think I'll do the right side and I'll let you guys do the left side. So I'll be taking care of the odds on this page. So the only difference is 5 is just simplifying, 7 is multiplying, and 9 is dividing. So the first thing of all factoring that I'm going to do is GCF. So on number 5, in the numerator, I can take an x out. So this is just my work for the numerator. And I'm going to get 6x squared plus x minus 2. And then from there, that's 3 terms, and that is not going to be easy factoring. So I'm just going to come over here and make my x. And I need factors of -12. They're going to get me to 1. And that will be 4x and -3x. So here's the x that was there. And then this is me rewriting the part in parentheses. And now I'm just going to group these. And in coming out of the 6x squared and 4x, I'll take a 2x. And then I'm left with 3x plus 2. Which is what I'll need the other set to be, matching. And when I'm done with that, I'll be taking out a -1. So as far as my numerator goes, you know, there was the x that I took out is the GCF, and then my other set will be a 3x plus 2, and then the 2x minus 1. Okay? All right, in the denominators, I'm going to switch colors for my denominator. The first thing I notice is a GCF, so I'm going to put it over here. And I can take an x squared out, and then after I take the x squared out, I'm left with 9x squared minus 4. Now this is not 3 terms, but it is a difference of squares. So joining the x squared, I can have 3x plus 2 and 3x minus 2. So that will join the denominator, 3x plus 2 and 3x minus 2. And then this is pretty, I think, a little on the easier side to see as far as canceling or simplifying goes. I can take out the 3x plus 2. And then these x's here, if you put those in a house, for instance, I'd have 1x left in the bottom. So when I'm done, my numerator will have 2x minus 1. And the denominator will have an x along with a 3x minus 2. The other thing it said, be sure to state all excluded values or domain restrictions. So that's the denominator. And as far as the denominators go, in this denominator, I can't have 0. And in this one, I can't have -2/3. And in this one, I can't have 2/3. And all I did was set those equal to 0 and got the x by itself. So x can't be 0 and then positive and -2/3, adding to that answer. All right, number 7. So on number 7, what I'm going to do is start with the left fraction. I'm going to factor that. So my numerator, there's no GCF. It's 3 terms. I'll go ahead and make the x in case you need it. I need factors of -5. That'll get me to -4. And that's 1x and -5x. And this is easy factoring. So this numerator will just become x plus 1 and x minus 5. And then my denominator There's no GCF, but I need factors of 9 that get me to 6. And those are going to be 3 and 3. And again, it's easy factoring, so it's just x plus 3 and x plus 3. And now I'm going to go to the other fraction. So in the other fraction, there is a GCF that I can take out, and it's a 2x. And then I'm left with x plus 3, which is actually, that's all I can do, so I won't worry about that. The denominator, there is no GCF, so I'm going to make my x. I need factors of -6. That gets me to -1, and that'll be a -3x and a 2x. So if I rewrite it now, because it's not easy factoring, and then I can group the first two and the last two. And the first set, I can take a 3x out, and I'm left with x minus 1, which is what the other set will need to be. And to get that, I'll have to take a 2 out. So joining the work there is I will have 3x plus 2 and x minus 1. Now, one thing I didn't mention is in this whole page, when you're just simplifying, you're trying to find out what can you take out from the top and the bottom, you can make houses in all of these problems. I think most of us will probably be okay not making houses for this problem, but one thing that might throw you off is just, for instance, this 2x right here. Okay, but as far as canceling things out, not much is actually going to go here. Just the x plus 3 is going to go, and everything else is going to stay. The x plus 1 on top and x minus 1 on the bottom, it's really close to canceling out, but it's not going to. So I'm going to move over here so I can get my final answer. And left in the numerator, x plus 1, x minus 5, the 2x, which I'll just put to the left. And in the denominator, I'll have an x plus 3, a 3x plus 2, and an x minus 1. And then what will I not pick as far as my domain? What are those excluded values? I do not want to pick, just looking in the original problem, over here, I'm not going to pick -3, I'm not going to pick -2/3, and I'm not going to pick 1. All right, number 9. So in number 9, we're dividing. Just remember, you don't divide by fractions, you copy dot flop, but when we copy, we are going to be factoring. So the top part is just easy factoring. There's no GCF. I need factors of -14 that get me to 5, and that'll be 7x and -2x, and it's easy factoring, so it'll be x plus 7 over x minus 2. Denominator cannot factor, but I'll wrap it in parentheses. Then I'm going to dot, and then I'm going to flip-flop it. So the x squared minus 4x plus 4 will actually be in the bottom, and I'll have a 1 in the numerator. And in that one, again, there is no GCF, but it's easy factoring, so I need factors of 4. They get me to -4, and that'll be a -2 and a -2. Easy factoring, x minus 2 and x minus 2. And now I will go through and take out those common things, which will be an x minus 2, just one set. So as far as my answer goes, what's left in the numerator is x plus 7. I do not need the 1, but you can put it there if you want. And then x minus 2. You could write it once with the little squared, or you can write it twice. And then what are those excluded values? Remember that, there's more than just the denominators that we notice. There is this denominator, and this denominator, and then this whole thing is a denominator to the numerator to the left. So luckily everything is the same. So as far as this goes, x can't be 2. Okay? All right, we are going to be moving on into, the adding and subtracting.